Hello. Today we're going to cover CICD with GitHub Actions. My name is Chris Ayers. I'm a senior fast track engineer at Microsoft. Um, there's some places you can reach out to me, and I'm going to have um, occasionally samples out on GitHub. So feel free to check out my blog or follow me, and we'll chat. So I want a level set as we dive into actions. So I'm going to do a quick high level conversation about YAML. We're going to talk about CICD and what that is. We'll do an overview of actions, and then we're just going to dive in. We're gonna build some actions. We're gonna explore some of the resources available and build some workflows. So YAML, you hear this a lot. It stands for yet another markup language. Um, YAML is used all over the place. It's used in Kubernetes, it's used in GitHub, it's used all over the place. And even though the basics of YAML are the same everywhere, the words and keywords and things that you use inside that YAML to configure something vary wildly. But the basics are the same everywhere. I am gonna. This website is a great example. I'm gonna switch to it and show how YAML translates down into JSON. It is it adds some features that JSON doesn't provide around comments um, but I will show it to you. YAML really only has 3 or 4 basics that most people need to use. GitHub uses YAML for the workflow files, and like lists, just start with a dash. That's really all you need to remember. They need to be the same indentation level. Um, Most things are just key value, so you put something, a colon, and then the value, and then objects on one line have the thing with the colon, and then below it indented are the list of properties. So I'm gonna switch to my browser real quick. Here's my browser, and this is that YAML validator site I talked about. So you know, I said lists start with a dash. So 1, 2. So you can now see, hey, this is valid YAML, and if I were to convert it into JSON, that would be an array of 2 items. Um, so what if I just did that? You can see that it's kind of confused. Doesn't seem to make sense. So let's look at that key value stuff. So key colon value. You can see what that looks like here in JSON. And notice it understands bools. So if I said try, that thinks that's a string. If I say true, it removes the quotes. It uses as a value. And then I talked about objects. So this might be an object, colon, and now I can list properties maybe of key value pairs. Maybe I want a list. Another object underneath it. So you can see how with just a couple of basic constructs of key value pairs, an object with a colon and a line, dashes again for the list properties, and then I can create nested structures of this is a list property. Yeah, that's an object because this is an array of. Anyways, so let's keep going. Because we're going to be using YAML, so I just want to make sure people are familiar. CICD. When we talk about CICD, this comes up a bunch, but continuous integration really is on a check-in. We automatically do a build, or it doesn't have to be a check-in. Maybe it's an event, but we automatically do a build. We automatically run our tests. Maybe we deploy it out to some sort of stage, and maybe we automatically run automated testing. So we have an automation that maybe deploys to dev or some environment so that we can test it. With continuous delivery, we have it all ready to go, but maybe there's a manual gate to release it to production. Someone has to approve it, someone has to review it or click a button. When we get to a point where we have confidence in our unit tests, we have confidence in our acceptance test, we monitor, logging and errors and failure rates and load testing all the way through. And once that quality of that quality gate is met all the way through, sometimes you can have deployments go all the way out to production. And this happens with high functioning organizations where they get to a point where maybe they're deploying dozens of times, multiple times a day to production. Small changes go through a pipeline and everything is automated, tested, and accepted and moves through. So now that we know what we're going to talk about, I'm going to focus a lot on the CI part, but I'm also going to touch on the CD part. So that for the deployment pieces, GitHub Actions has been around for a couple of years now. GitHub Actions are event driven. So that means we can have multiple commands that we run after an event. And there are capabilities for conditionals. So like if it's in this branch or if it's this event, run these things or not. But I just want to get some terms and ideas out of the way, and then we'll actually explore it. So an event happens, something happens, and that triggers a job. A job is made up of one or more steps. So a step might be an action. A step might be a shell command or a series of commands on a bash shell or a PowerShell. And you can take outputs from one action and use it in another. You can define event variables for this job so that all of those steps and shell commands can share those values. You're not limited to just one job though. There might be multiple jobs. Now each job executes on what's called a runner. And this is the jobs will try to run in parallel. If you have multiple runners, so if you're using GitHub hosted runners and maybe you have all these jobs that are independent, they could potentially spin up and run in parallel. You can set dependencies on jobs. You can say, hey, this job is waiting on the output of this job. So this is my deployment job. This is my build, my CI job. So this one might do compile, run a validation, upload the output to a package or an artifact. And then this job might be download the artifact, validate against the cloud, and deploy it. So our jobs, and I highly recommend separating those type of steps, those building a thing from deploying a thing steps. That's been very important for a long time. So we've got these events, we've got jobs, we've got runners. The runners are hosted in the cloud. If you use GitHub hosted runners, they have them for Mac, Windows, and Linux, or you can deploy them for yourself on-prem. Now, I love talking about GitHub hosted runners because I think this is something people don't realize, and I like to share it. So these are the varieties of runners available. And if you notice, these are links. And if I follow this link out, this is a list of all of the software installed on a runner. I've seen people using a runner go, oh, well, I have to have this type of software. I have to have that type of software. And they go and like try to install it, try to configure it. And I just want to point out, there's a lot of things that are already set up and installed on these runners for you. You already have Ant Gradle, you already have Ruby, they already have Docker and Compose. So there are many tools that you might think you need to install, configure, and use that are already installed and configured, and you can just take advantage of them. We have the CLI for Azure. There's multiple versions of Java and PHP. It's kind of incredible because what's awesome about these type of runners, and I'm going to show you, they take on all the maintenance of these, so you don't have to. So you automatically would get updates for the OS. So they patch the OS. That's something people don't think about when they run um, build machines for themselves, that you have to update and maintain sometimes those build servers, software updates, tooling updates, and self-hosted runners will update themselves, but they won't update the tools and packages. Um, what's great is you can use on-prem machines, you can use cloud machines, you can use the services you already have configured, which is great. Now, when you're running in the cloud, if you have a really big code base, if it has to download and recompile everything every time and your build takes an hour, that means every single time your build takes an hour. If you want to cache the results of your last build, so you only build the differences, so you bring your build times down to like 5 minutes, that's where self-hosted runners might work, because you don't have to do a clean wipe everything every time. It could be, hey, just build the differences. Those are um, options. You do get some free minutes on the GitHub plan, and we can talk about some of the billing on the plan if we need to. But yeah, you can use as many runners as you want, free to use with actions. So let's actually dive into workflows. Let's really understand what's happening. They all live inside your .github folder slash workflows. Any repo, if you create a workflow, they live in .github workflows. Now there is, and we're going to talk about it, there are templates that you can set at an org level or a repo level, where it will be I want to make a new workflow based on this template. It'll copy it and then you can edit it. And we talked about GitHub Actions trigger on events. There are lots of events. There are lots of triggers. Um, you can schedule. So let's say we want to schedule a build or an interaction, or hey, we did something with a workflow or a repo and we're going to manually trigger a build. Or maybe there was an issue created, or a deployment, or someone did a push, or someone did a pull, or a pull request, or there's dozens of events that can trigger workflows. So now that we know the concepts, let's go take a look at some actions. All right, the documentation, phenomenal. I will share these out, but learn GitHub Actions. This walks you through a lot of it, and it will help you create workflows. So, like right here, this is what a workflow looks like. We have a name of our workflow. This is the name that will be shown when we run our workflow on, and we have our trigger event. So we talked about that wide variety, and then we have a list of our jobs. Notice this is the key value stuff in YAML. This is an array, and now we've got our jobs, and so there's a job here. Check Bat's version, and we get to say what runner we want to use it on. So we want to use it on one of those Ubuntu hosted runners, and then we have our series of steps, and this is where we use actions. If I go out to GitHub repository, so I have a few GitHub repositories. I'm just going to go out to one of mine. So here I have a .NET application. If I go into actions, you can see I have a couple, but I can make a new workflow. And one of the things that GitHub Actions and GitHub does is it kind of can detect what are the languages that are in use in your repo, and maybe it will make some suggestions. I could start out with a blank one. I'll show you about this one. I have a template deploy, but here's some suggested ones on how to build. And if I scroll down, there's a few more additional ones around deployment. But let's just start with this one. So I say configure, and you can see it gives it a name of a workflow. It's going to put it in the .github workflows repository. This has two triggers. So on a push, just to the master branch, it will run this workflow. And on a pull request, just to the master branch, it'll run this workflow. This is not going to happen on every branch. This is not going to happen on every action, only on those two actions on the master branch. And then I have my jobs. So I have a build job. So so these names are important because you can reference those outputs later. You can see it runs on Linux, and then it has these steps. if it just says action slash, and you can see it over here, this marketplace stuff. So if it just says action slash, why don't we go take a look at one? So if I look for that checkout action, I can click on this link and it brings up essentially how to use this action in my workflow. And you can see this is provided by Actions. So this is by GitHub. This gives you like the name of it. So you can do, this is the short form where it's just saying, go execute this action. I can give it the longer form where I use the name, I provide additional information. So I can provide a repository. Um, I will talk about that in a sec. That is a variable. I'm referencing a variable. But you can see all the options: SSH, LFS, if you want to pull it clean. And if I want additional information about this specific action, I can actually click the link and go out to its full marketplace listing. And you can see, hey, look, the blue check mark means it's a verified creator. I can see that it's got passing tests, it's got lots of stars. If I'm curious about issues, I can go look at the issues, but this will now go through and I see that full information again and also see some scenarios where maybe I'm trying to figure out how to leverage this action. So I want to check out something about the head. Well, this is how you do those type of things. Maybe I want to do a certain path or multiple repos. So I can take an action and learn how to use it effectively. We just saw that there was a variable. So there are environmental variables that are defined um, by the runner, by the action, by GitHub. You can see some of them are maybe in the environment. I've defined environment day of week, and now I can reference it with that dollar bracket bracket syntax. But there's also a number of them that are defined as we run. Like, are we in a CI environment? This maybe is important for something like npm. What's the name of the current workflow or the run? So maybe I want to base a build ID based on my run number. What job am I currently executing and what path am I in? Um, what reference or branch triggered it? Or what's my SHA? So you can access those while you're executing your action, your workflow, and you have all of these available to you. You know, and this is the full syntax for that workflow. You can see I talked about the push pull. We also have that full array, and you can list out the events. This is an amazing reference that you need to. I keep open quite a bit. How do I set my environmental variables? Maybe for a job step, I'm curious about how to pass input parameters to an action. So with key value, um, these are all there. So let's go back to this. You can see I've got my checkout, I've got my .NET. I'm specifying which version I want to use. It's running a restore, it's running a build, it's running a test. So I can create a pull request if I want. That way, let's take a look at this. So you can see I've got some existing scans that are going to run, but I was also making this specific one, and this says on a pull request into master, run this workflow. Well, I'm doing a pull request in the master. So if I go over here and look, this should be the one that, yep, patch 1, just opened it, in progress, and you can see this is a summary of my workflow. And here's my build. So it does some setup before it does anything else. And you can see on the setup, if you're curious, what OS are we on? What's our virtual environment look like? What permissions did it have? So did it have permissions to run actions or do checks? What actions are being used. So it knows I'm using a checkout action and a setup.net action. So I can see the output of each individual action and kind of dive into those settings that are being output. You know, run setup.net. That was the version we provided in our workflow file. So that ran, did the .NET restore, build. So I can see all that. We have a green symbol. It passed. And going back here, you can see all my other ones ran as well. So I'm having multiple workflows triggered off the same event. That's something that happens quite often. I have one for CodeQL. I have one for linting. I have my existing one that was already there. I had some security scans. All of those are running in parallel because they're each independent, running through a different workflow, different trigger. And this type of, I want to make a new workflow, they have a lot of starting places. We have one for Node. There's one to help with deployments. And like I'm doing a .NET app, maybe I want to deploy it out to an Azure web app. So if I do this configure, you can see here there's what's your web app name? Where did you put your code? They have a build step, like I talked about, where they're building and publishing their app, and then they're uploading an artifact. So they're using this upload artifact action. This is how we can transfer information between different steps in a workflow. So we've done our build, we're uploading it. You can see it's giving it a name of .NET app. Here's that information about it. It will retain it so many days and then deploy. So this depends, it needs this build to run. So now we're building a graph of jobs. This is going to be named environment, and it's going to take, you notice steps, deploy to web app outputs. So it's going to actually get an output from that step to get the URL. And it's going to download an artifact. So it's going to download that .NET app that we published in the previous step. So that's where names are definitely important here. But this will deploy the web app out to Azure, web app name, the publish profile, and then that path. Now, if we leveraged this demo, notice it's using the environment variable, which we defined up here, but it's also using a secret. Secrets, they exist inside of a repo under settings. There's a couple of places we can define secrets, and I actually have a better example of this one for my feature flag talk. So in feature flags here, I leverage environments. So I have a couple of environments that each have secrets. So like my app config quick start has an app name that is an environment secret. And that has the exact same name as a secret. Launch Darkly has that name as a secret and an additional one. So this has 3 different environments defined. And then if I look at my secrets, you can see this is where it lists out those environment secrets, and you can see which environment has which secrets. And then I have some secrets that are just on the repository. So these maybe are global to the entire repository. And then you can also have organizational secrets that apply to all of the repos inside that organization or inside that account. So you can have org secrets, repository secrets, and then specific environment secrets to leverage in your workflows. And let's take a quick look at that. So for this app config dynamic one, you can see I have a build and a deploy, and you can see I have some artifacts that were created during that build. Let's take a look at this workflow. So I'm leveraging paths. So I'm saying only trigger this on main where I have these paths included. Like remove all the paths and then only add these two. And then workflow dispatch is if I want to manually run it. Got a couple of environment variables, and now I've got this job. Notice it's using that environment path multiple places throughout here. This lets me easily reuse my workflow file because I can just maybe copy it or make a template out of it and update my path and project. And then down here, when I do my deployment, so secret, Azure credentials, secret subscription, secrets RG, secrets name. So these are all just called secrets. And I just want to bring something up. I just want to quickly show you. If I look at my secrets, these are environment secrets, these are repo secrets. That one is a repo secret. It doesn't matter if the secret is environment, repository, or org. You just say secrets dot. You don't have to. I want to make sure you don't try to do like .env for like, oh, it's an environment secret. Env is going to be like your environment variables. So I want to make sure you don't get those two mixed up. So yeah, that is what multiple stages looks like. And you can see I'm exploring through. I can look at my deployment. I can still access my logs. You can see the download and running the publish. Touch on a couple of other things. I mentioned there's a way to reuse workflows, so that's all documented as well. There's two ways, and they both kind of have some shortcomings, so I just want to touch on those. Going back to my repository, so if you ever want to do org level or account level stuff, you make a .github repository, a public.github repository. And you can make workflow templates, you can make issue templates. This is where you can make templates for things that you want to reuse. Now, you can see I made the CI one. This is just a very basic one, and it says default branch as a variable. And I've got a build with an action and a script. The other thing is there's a properties JSON that sits right next to it. This just defines what it is and what it does. You can give it an icon, a category, and file patterns. This is all documented in here, but it does have limitations. Like but once I've defined this as a workflow at my organization level, if I pick any repo, hello world, and I say actions, here it is. So this is my org, and here is that action that is an option for me to create. And if I create it, it builds it with that name and fills it in. The only thing it really changed was master. There are a couple of variables that you can do to swap stuff out, but it's just pretty much a copy. They're not linked, and you're not like calling the old one. It is a copy, and so at this point they could start to diverge. That leaves you with a different option. So there is reusable workflow templates, and I wanted to touch on that one again also. So looking at workflows, you can define a reusable workflow template. Now this template has the event on workflow call. Again, everything's event driven. So on workflow call, it requires a username to be inputted, and it requires a secret with the name token. So now I have a job, I'm doing job stuff. It's gonna pass that input and run the script, and maybe it's gonna do something else. How do we call that? Here again is where there's some limitations. So let's say I want to call it, I've got my normal name and my normal triggers. If I want to manually call it, it has to be its own kind of job build. Like you can't just say, I'm going to use this workflow as an action. No, this is a whole job. So you have to do it as a job. You can pass in those variables. You can pass in secrets. If I wanted to do the dollar bracket secret, I can do that. But you can see I'm referencing the path in the repository to that specific workflow. I'm saying at main, which is just the latest. For security, you should probably put a SHA-1 or a commit hash. But what does that look like when we run it? We have these 3 stages, and we can see that it passed in some variables to trigger those things. Composition is one of those steps that we start getting into as we start building more enterprise actions. So that's why this is important, like trying to understand some of these reusable workflows. Another thing that's important, I mentioned the environmental variables. There's some context that are provided to you. These this documentation under context will list out those type of variables in context if you need to access them. Like what's defined by environment, whatever environmental variables you pass. What's defined on job dot container, job dot services. What's defined on step. So these are the context that you can access while running, so that you can understand or reference them in your workflows. Additional stuff. Now, one of the last things I want to touch before we go is caching of dependencies. I know a lot of times people, when you have a lot of dependencies and you run multiple workflows, you don't want to just have to re-download all of those npm or NuGet or pip dependencies for this big repo. So there's a caching action that you can leverage, and they have it built into setup Node and setup Python, where you can define that caching. So if we look here, the setup Node action is out in GitHub, and we can be like, uses setup Node with 14. And if we look a little farther, we can tell it to cache npm. Or if we're in a big mono repo with dozens of Node projects, we can say, for this workflow, cache that subdirectory's package lock. All of these are built on the cache action. Building your own cache action stuff might be fun, but here is a list of how to do it for your specific language. So for C#, this is what it might look like. I might say uses cache, and I point it at a package, and I give it a key. So there's a million different use cases. They'll leverage the documentation, leverage the marketplace, leverage the actions. That is, I think, the best advice I can give you on a lot of this stuff. Trial and error is okay. You don't expect a workflow to work the first time every time. As I was showing, I had a number of repos that I use for different things. One of them is like my feature flags repository. And if you look back at like my run history, I have failures as I tweak the naming, as I start evolving my build, and I'm like, no, I want it to work a different way. I want additional functionality. Yeah, deploying to like, so the deployment steps. Um, I leverage a lot of workflows and actions that are officially supported and officially provided by vendors. So if I come over here to the marketplace, if I wanted to deploy to Azure, so blue check mark, verified by GitHub, it's by Azure. There's a lot of different marketplace actions. I can go out and look at the listings of these. You can see GitHub Marketplace Actions login. So a sample workflow with login. So I can log in using credentials. They just now have recently added OIDC support, which is awesome. Like I said, it's in public preview for um, public clouds, but much better than always having to set your credentials. But looking at any individual cloud's marketplace actions, that is, if you need to deploy to AWS, and what actions. So you can see these are provided by AWS Actions. They have the SAM CLI, ECR. You also have ones provided by other people that maybe have a little bit better syntax. So GKE. If you need to do GKE, there's GitHub, Google Actions, Google Cloud. Yeah, authentication. So you can come here and look. I would suggest look for the blue checkbox. There are some amazing creators out there making awesome actions. Um, Take a look, take advantage of them, dive into them. There's ones on code coverage and code review. Um, but I want to thank you for the time. I hope this was helpful, and I hope everyone has a happy holidays. So thank you.